Okay, let's begin. There's one instruction that's given. For all questions, take the gravitational field strength, G, near the Earth's surface to be 10 newtons per kilogram. So this first thing you need to know. Okay, I hope you highlight it. This value is 10. Okay, so that little g over there represents gravitational field strength. Just like our magnetic field strength. Different magnets have different field strength. Depending on how strong it is, how strong the magnet is, how weak the magnet is, and the distance you are away from the magnet. So here, instead of magnets, we have planets, which have these field strengths. Okay, so first question, which of the following about mass is true? So the answer is B. Okay, mass is the amount of matter in a body. So for example, all of us, we are made of atoms and molecules. We are made out of matter. So all these things, they have mass. And it doesn't change regardless of where you are. Okay, whether you're on Earth, on the moon, far away from the Earth, out in outer space, your mass remains the same. Because you did not lose any piece of you when you are transported from one place to another. Okay, so answer is B. Now, if the answer is B, what does this tell us about A? Mass is equal and it is interchangeable with weight. What does this tell us about option A? Is A true or false? False. So, this tells us that mass is not equal to weight. They are different. So as physics students, you better be able to tell the difference. Mass and weight are totally different. So what about option C? Mass varies according to the gravitational field strength. It doesn't. Mass is a constant. Rather, weight varies according to the gravitational field strength. So, although these are MCQ questions, there are many things that you can learn from answers that are options that are not correct. Okay, and finally, mass varies according to shape. Obviously not. Okay, shape has nothing to do with the mass. Okay, so now for question 2, which one represents how the weight varies with mass at a particular point on the surface of the Earth? So the answer will be B. Can I have a show of hands? Who got this correct? Because I don't think this is a simple question for a Sec 1 student. Have you all done graphs in mathematics yet?
No.
Graphs in mathematics? Not yet? Okay. Okay. Sure. Okay, now tell me, what is the relationship between mass and weight? Is there a formula that we can use to equate mass and weight?
Mass times gravitational field equals
So W equals to
to M times
mg. Have you memorized this already? If you haven't, it's time to memorize it. This one, I'm going to highlight it because it is so important. It will not be provided during your test. You are expected to be able to apply it. So this W over here refers to weight. M refers to mass. G refers to the gravitational field strength. So while we are at this, let me give you the units. Or rather, you tell me the units. What are the units for weight? Ashley, what are the units for weight? Kilogram? Are you sure? Okay, I'll give you another option. Which of these letters has the unit kilogram? we've got weight, we've got mass, we've got gravitational field strength. Which one of these have the unit for kilogram? Weight. Okay, anybody disagrees with her? Chae-yong? Why do you disagree? Then who is Chae-yong? Who? Oh, sorry. Yongshi, sorry. Yongshi, right? Okay, because I didn't see the next line. Why do you disagree? What is mass supposed to have? Okay, the units for mass is kilogram. Okay, that's correct. Then what about for weight? Ashley, are you able to tell us the answer now for the units for weight? Still cannot? I heard somebody give the answer. Who wants to help? Yes? Newtons. Ashley, does Newton sound familiar to you? Okay, so here we've got units Newton. Do you remember when did we come across this word Newton?
Wait.
Not pressure? Anybody? Force. We came across the unit Newton in force, in forces. That is because weight over here is a force. Weight is a force. That is why it has the same unit as force, which is the Newton. So the gravitational field strength will be in Newton per kilogram. Okay, why am I talking to you about all these things? Yes, you need to memorize, but you also need to understand. Which of these letters is a constant at Earth's surface? W, M, or G? For all different materials on Earth, which one is a constant? G. Okay, gravitational field strength on Earth, near the Earth's surface, is a constant. What is the value? You also need to memorize the value. What is the value of G near Earth's surface? 10 newtons per kilogram. This one over here is 10 newtons per kilogram. It is a constant on Earth's surface. Okay? Now, for different people in the classroom, for example, myself, I have a mass of 70 kilograms. Okay? So, for me, I've got 70 kilograms over here. What is my weight? 700 newtons. Okay? So, as my mass, okay, so let me give you another different mass right now. Something of a lower value. Let's say my water bottle. It has a mass of 1 kilogram. Okay, water bottle, let's use another color, green. My water bottle has a mass of 1 kilogram. What is its weight? 10 newtons. Okay, let's try that cupboard over there. Suppose it is filled with books. Let's say it has a mass of 100 kilograms. 100 kilograms for the metal cupboard. What is its weight? 1000 newtons. We simply multiply it by this constant over here, okay, which is the gravitational field strength. Now tell me, as the mass increases, what happens to the weight? It increases. As the mass increases, the weight increases. Now look at the options that we have for our graphs. A, B, C, and D. Which one confirm wrong? Which one confirm wrong? C, right? Because it shows that for part C, as the mass increases, I see that the weight decreases. It goes this way. Okay? So in part C, in option C, as mass increases, weight decreases. So this must be wrong. So I'm left with 3 options, A, B, and D. Let's talk about A. Okay? Let's talk about this point over here. According to graph A, when mass is equals to 0, when it is 0 kilograms, what is the weight according to A? It is more than 0, it is not 0. So for example, this, because 0 is over here, right? Let's say this is, for example, 8, for example. It tells me that when mass is 0, weight is 8. Can that be possible? Is that possible? According to our equation, W equals to mg. If mass is 0, what should weight be? 0, because 0 times 10 is 0. Therefore, A is also out. Now I'm left with B and D. What is the difference in the shape for B and D for the graph? One is a straight line, the other is a curve. Okay, so how then do we tell the difference? This is why I say that it can be a little challenging for Sec 1s because you haven't really learned this in maths yet for your graphs. What is a straight line? What's not a straight line? Okay, so let me try and explain this to you. W equals to mg. If you draw it to scale, when m equals to 1, 2, 3, 4. 1, 2, 3, 4. When m equals to 1, what should W be? It should be 10, right? Okay, so this is 10. Make sense to you so far? When m equals to 2, what should the weight be? 20. So this is 20. When m equals to 3, W equals to 30. And finally, when m equals to 4, what should the weight be? 40. Okay, this graph makes sense to you? Okay, let's try for the next one. We still have our 1, 2, 3, and 4. 1, 2, 3, and 4 kilograms. Now, same formula. When m equals to 1, our weight should be 10, right? When m equals to 2, our weight should be 20. When m equals to 3, m should be 30. When m equals to 4, our weight should be equals to 40. Okay, based on these two graphs, besides talking about the shape of the graph, what else is different? The numbers are the same, 1, 2, 3, 4, 10, 20, 30, 40. I want you to focus on this part. Is there a difference that you can tell? Numbers are? Squeeze together. Which one is squeeze together? B or D? D is squeeze together. Can you see? The gap between 10 and 20. 20 and 30. 30 and 40 is getting smaller and smaller, right? Then is that to scale already? I mean, if you have a ruler, between 1 and 2, 2 and 3, 3 and 4 should have the same length, right? Same distance. So based on this, which one is correct? B or D? B. The gap, the spacing between these values are the same. Okay, please bear with this, there's some problem with the cable. Okay, so this spacing, they are the same in part B. Whereas in part D, the spacing gets smaller and smaller because it is a curve. Therefore, D also cannot be our answer. Our answer is B. Okay? Next one. Man measures his weight on Earth, 600 newtons, mass in space. What is it? Which is you see, we are trying to equate weight with mass. When you see these two happening, what is the formula you should be using? Who is Kylie? What is the formula we should be using when we have mass and weight? W equals to mg, excellent. W equals to mg. Out of all these, W, M, and G, which are the things that we already know? What can we substitute inside? What can we substitute into this equation? Chloe. The weight is 600. Okay, so substitute in 600 equals to, what else do we have? I'm supposed to write down M, isn't it? Do I know what mass is? I don't know what it is, so I copy it down. Don't need to think so much. What about the G over there? Did the question tell me it is 10? Didn't tell me. During the exams, we are not going to tell you also. You are expected to know that you have to substitute in the value of 10. Okay, so 600 equals to m times 10. What must m be? M must be equal to 60, because 60 times 10 is 600. Therefore, answer is B. Simple, the application for the formula. Okay, now next. The moon has gravitational field strength of 1/6 of Earth's gravitational field strength. Find the weight on the moon. Okay, how shall we do this? I again want to find the weight. Divide by what divided by 6 times 1? The mass of him on Earth divided by? Why? But what is 1/6? Don't be too quick to jump into the question. You must understand it first. Understand what the question wants and what it is describing to you. Okay? Field strength. Yeah, field strength is 1/6. Now this man, he has a mass of 60 kilograms on Earth. He transports himself to the moon. Does his mass change? So what is his mass on the moon? It is still 60 kilograms. Same as on Earth. But what is it that changes? His weight. Now when he goes to the moon, do you think his weight will increase or decrease? You know? Decrease, because why? The field strength is weaker. Yes, it is lower. How much is it compared to the Earth? On Earth, it is 10 newtons per kilogram. On the moon, how much will it be? According to the question. How much is the gravitational field strength on the moon? 1/6 of Earth, right? And on Earth it is 10, so 1/6 of 10. So this is the working that I expect. G, what does G represent? Class, what does G represent? Gravitational field strength. Okay, gravitational field strength. But now, there are two different types of gravitational field strength in the question. There is one on Earth and one on the moon. If I write G like this, do you know what I'm referring to? Don't know, then how? So this is what I write. G. At the bottom I write in small letters MOON. Now this means I'm talking about the gravitational field strength on the moon. Okay, and this is equal to 1/6 that of the Earth, which is 10. So this gives me 5/3 newtons per kilogram. Right? That's the gravitational field strength on the moon. Now, we want to find the weight. So we take weight, W equals to, what is the formula for weight again? You see, I'm asking you to repeat because you are expected to memorize. W equals to mg. Okay, so let me write down mg again. If I write down mg like this, do you know what does this g represent? So how do I edit it? Small letter again, right? Moon. Because now I'm finding the weight on the moon, so I need the gravitational field strength on the moon, which will give us the mass. We found it was 60 times 5/3. So this gives me 100 newtons. 100 newtons. So his weight on the moon is less than his weight on Earth. Okay, now I want you to compare the value, the difference in the weight on Earth and on the moon. 600 versus 100. Mathematically, right, what jumps out at you? What do you know about what is the relationship between this 600 and the 100? What's the relationship? Times 6, right? Or rather, divide by 6. From 600 to 100, you divide by 6. Why divide by 6? Because the field strength is 1/6 that on the moon. So this working over here can also be simplified if you know your mathematics well, if you know your physics well. I will also accept weight on the moon equals to 600 divided by 6, we get 100. Okay? So we will also accept that. It is the same. Now next. So here, weight of some of the masses on the surface of 4 different planets. So when they tell you 4 different planets, I want you to put down a note over here. Different gravitational field strength. Okay, these 4 different planets, they have the different gravitational field strengths. And our job now is to find out which one has the greatest gravitational field strength. So what is the equation? What is the formula linking mass and weight together? They have a relationship. What is the equation that links mass and weight? Yes? W equals to mg again. You are right. W equals to mg. So how many formulas have I used for this worksheet so far? Only one. And it is W equals to mg. I hope that tells you how important it is. Huh? So here we've got weight, we've got mass, and what does this G represent again? Gravitational field strength, which is what they want us to find out, isn't it? So if I leave the equation like this, W equals to mg, I'm trying to find out weight. But I don't want to find out weight, I want to find G, right? So I want to make G the subject. Have you learned to make G the subject in maths? Also not yet, okay. So I want G to be by itself. I want G to be by itself. I don't want it to be attached to the M over there. Currently, I've got G multiplied by M. I don't want the M because I want to find G. So what should I do to get rid of the M? Divide by M. Okay, let us divide by M. Here I divide by M. This side I also divide by M. So on the right hand side, I've got G, right? Because mg divided by M is simply G, isn't it? Then on the left hand side, what do I have? W over M, yes. So now I have a formula to find gravitational field strength. Question says, which one has the greatest gravitational field strength? I know. I just need to take the weight divided by mass. I will get the gravitational field strength. So here I will create another column. Okay, so let me just put it over here. G equals to W over M. Okay, so let's remove all this. And I've got a new column. It is called G. Okay, the first one. W divided by M. 20 divided by 0.5. What do we get? Calculator, everyone? Equals to 40. Okay, next one. W divided by G. So 20 divided by 2, we get 10. 40 divided by 0.5, we get 80. And the last one, 40 divided by 2, we get 20. So from here, which one has the greatest gravitational field strength? C. Okay, do you understand how to do this now? Any questions? Okay, then moving on. An apple has a mass of 0.75 kilograms. This refers to mass. It hangs on a branch that can support maximum weight of 10 newtons. What does this statement mean? Can support maximum weight of 10 newtons. What happens if it is more than 10 newtons? It will break. Okay, the branch can support 10 newtons. If it is more than 10 newtons, it will break. So now, determine the minimum force required to pluck the apple from the branch. Okay, do you think the answer is just 10?
10.1.
Is 10 point, must it be greater than 10 in order to pluck it out?
Yes.
That's already what? 7.5 newtons, okay. What if the apple is very, very light? Let's say it is 0.1 kilogram. Do I need a greater force or a less force? It is very, very light. So I need a greater force, right? Makes sense. What if the apple is very, very heavy? Let's say it is 0.9 kilograms. Do I need a greater or less force? Less force. Okay, if you are able to tell me all these things, it means that you understand the question. And that the mass of the apple affects the weight of the apple, and that affects the amount of force required to pluck it out. So the minimum force required will be, in this case, 10 minus 7.5, okay? So W equals to mg, W is the weight of the apple. Weight of apple. So that's 7.5 newtons. The minimum force will therefore be 10 minus 7.5 to get the answer of 2.5 newtons. Okay? So anything 2.5 or greater, you'll be able to pluck it out. Okay? If it is less than 2.5, you cannot. Alright? Now, you don't have to. Okay, is there anybody who disagrees with this answer? Anybody who disagrees? Then can I have a show of hands who got this correct? 2.5, you have the value of 2.5. Okay, thank you for the hands. Anybody wrote 2.6? Anybody? Nobody? Okay. The reason why I bring up 2.6 is because I don't know whether you will be thinking, looking at the question, it can support a maximum weight of 10 newtons. That means you can take 10 newtons, right? By right, it should be able to. Then only if it is greater than 10, then it will snap, right? Then it will break. So at the moment, if I use 2.5 newtons, I plus 7.5 newtons, I get 10 newtons. So by right, it should be able to stay there, right? By right, it should be able to stay there. But anything just a little bit more, just 0.000001, it will break already, isn't it? So how do you write down 2.5000001? You can't write that. So for this question, we'll just write down minimum force is 2.5. Okay? With the understanding that anything just a little bit more than 2.5, it will break already. Okay? So don't go and stress yourself over that little detail over there. Okay? So the answer is 2.5 newtons. Okay, next. State 3 differences between mass and weight. There are quite a number of differences, so I'll just put them all on the screen for you. I've got 1 point, 2 points, 3 points, and 4 points over here. According to our notes, gravitational field is a region. You need to understand that it is a region. Okay, it is part of space. It is somewhere. So this field is a region in which a mass experiences a force due to gravitational attraction. Just like our paperclip, this magnetic field is a region where this magnetic object experiences a force due to magnetic attraction. Then this one over here is just all changed to gravitational. Okay? So next one, gravitational field strength. So you know that gravitational field is a region. Strength is not a region. Strength is the how strong it is, okay, as the name suggests. So the gravitational field strength will be the gravitational force acting per unit mass. Okay, let me put this down in symbols. Gravitational force. What is another name for gravitational force? Weight. W. Unit mass. Okay, what do we use to represent mass? M. What does this per represent in mathematics? What does per represent? A slash, right? Right? We've got a slash, like your 10 meters per second, 5 milliliters per minute. Okay, so this one will be our slash, which is actually a division, isn't it? This slash actually means divide, ma. So this tells us that W over M, right? Force per unit mass. This is W divided by M. Does this sound familiar to you? W over M? Did we do it just now? What is W over M equal to? G. We saw earlier on that this is equal to G. That is why I say that if you can memorize the definition, you will be able to get the formula. If you know the formula, you should be able to tell whether your definition is right or wrong. Okay? So don't need to, if you study smart, there is less for you to study. Okay, so next. Describe the difference in gravitational field strength of the Earth on a bowling ball, mass 10 kg, and a ping pong ball, mass 10 grams. Gravitational field strength. Okay, so whether it is a ping pong ball, bowling ball, how does the gravitational field strength differ? Any suggestions? Joseph? Gravitational field strength. Look at this diagram. What? Remember all these lines, they represent they indicate the strength. I hope the rest are thinking. Tell me something you know about gravitational field strength. Anything. Okay, he tells me that W equals to mg. He's not wrong. But I want something about gravitational field strength. So out of this W, M, and G, which one is the gravitational field strength? G, okay? G is the gravitational field strength. What else can you tell me about this value, this G over here? W divided by M equals to G. What else can you tell me about G? You are giving everything that is correct so far. What else can you tell me about G? A number. Huh? 10. Okay, the number is 10. 10 newtons per kilogram. 10 newtons per kilogram. So, this number 10, it is for near the surface of Earth only. Okay? Doesn't matter whether it is for the cupboard, whether it is for Mr. Wong, whether it's for my water bottle. We all have different masses, but we are still going to use the same value of gravitational field strength of 10 newtons per kilogram. So it doesn't matter whether it is for the bowling ball or the ping pong ball. The gravitational field strength is the same. Okay? And Joseph gave us the value as 10 newtons per kilogram. So that's extra information. You must understand what we are talking about. Link them all together, yes. Yes, the mass of the objects are different. What's your point? Continue. Okay, so Tom says that hey, the masses are different, so the weight should be different. You all agree? Agree or disagree? The mass is different, so the weight must be different. Yeah, you're right. The mass is different, the weight must be different. But it doesn't change the fact that the gravitational field strength is still 10. It is 10 newtons per kilogram. For 1 kilogram, the weight will be 10 newtons. For 2 kilograms, the weight will be 20 newtons. Okay? Okay, we will stop here for now. I want you to read your notes for the next chapter. Okay, there are many blanks, but just give an